Hi, in this lesson you're going to learn how to do a basic t-test using the TI-Nspire CAS calculator. The question that we're looking at is that a food packaging company machine is supposed to dispense 500 grams on average into each package. A random sample of 8 packages of the product gives the following contents. There's the contents. An analyst is required to check the machine is not dispensing too much. So we have our 8 values there, and this is a sample of the full population. And through some calculations we've worked out that it's 505.5 grams. This is obviously quite easy to do with the 8 numbers. If however you wanted to do this on your calculator, you would put them into a list and spreadsheet. I'm going to call it mass, and you can perform our standard statistics test, StatCalcs, one variable statistics on one list, mass, and the results will go into column A. Okay, and you can see that the sample population mean is 505.5 grams. I'm going to delete these values now because they're not going to be helpful for us when we do our t-test. Now, if we're going to set up to do our t-test, I'm going to scroll down to the right part of our page. We need to put the following information in. We need to have our null hypothesis, and we have to have an alternate hypothesis. So, our null hypothesis is that the machine is dispensing exactly 500 grams. Now that we've worked out the sample population, our alternative hypothesis is that the sample is actually greater than the 500 grams. So how do we do the t-test? On the calculator, you leave the data there and you go menu. We then go to statistics, we go to stat tests, we go to t-test. Data input method is data. Mu naught is the average as we would like it to be. So the machine is meant to put in 500 grams. Our list of data is mass, our frequency list is 1. Now our alternative hypothesis, we are saying, based on the sample mass that we saw of 500, sample mean of 505.5, that mu naught is actually greater, our sample mean is greater than the actual mean of 500. i.e. we're saying that the sample mean of 505 is greater than 500, which is correct. And we're going to put the results into column B, and we click OK. So here we've performed the t-test. There is our t-value, but the value we're interested in here is the p-value of 0.038. To convert this to a percentage, you multiply by 100. And so now we can say that we have 3.81%, which in mathematics applied, as it is less than 5%, we say is statistically relevant, and it means that we can disclude the null hypothesis, or we can say that we've disproven it, and we will accept the alternative hypothesis that it is not the sample size, sample population alone that is causing the increased mean, but it actually may be that the machine is not working correctly.